Electric current does not spontaneously flow. We need something to drive it through our circuit so we can make use of it in the form of light, heat, or a breeze. You may already know that the battery is responsible for driving the current. But how? Let's find out. We know that water flows from a higher level to a lower level. When two bodies are kept in contact, heat is conducted from a body at higher temperature to a body at lower temperature. Similarly, electric charge is said to flow from a point at higher electric potential to a point at lower electric potential. To understand this concept, we should understand what exactly we mean by the term electric potential. Consider an example in which the body of mass m has to be raised to a height h from the ground. We know that work equal to mgh units of energy will first have to be done in lifting the body against the downward gravitational force exerted by the earth. At this position, the body has acquired mgh units of gravitational potential energy and has the capacity to do work. Similar is the case with electric charges. Electric charges may be positive or negative. We know that unlike charges attract each other, whereas like charges repel each other. Consider that a positive charge A is fixed at some point in space. If we bring another positive charge B near it, then the charge B experiences a repulsive force due to charge A. During its motion, the work that is done to overcome this repulsive force gets stored in the form of potential energy. The potential energy possessed is called electrical potential energy. Therefore, in this case, work done is equal to electrical potential energy. The closer the charge B moves towards charge A, more is the electrical potential energy acquired. Now, if we release this charge, then its potential energy gets converted into kinetic energy, and the electric charge moves away from the fixed positive charge A. Now, if 3 to 4 charges are brought near the fixed charge A, then they also experience the repulsive force. So the amount of work required to bring these charges is much more than in the previous case. Similarly, consider a fixed negative charge. If the positive electric charges are placed near this negative charge, then the positive charges experience attractive force. Now, if the positive charges are to be moved away from the fixed negative charge, then work has to be done against this attractive force. Again, the work done on these charges gets stored in the form of electrical potential energy. Hence, in any case, more amount of charges means more amount of work to be done, which means more will be the electrical potential energy possessed by these charges. That is, electrical potential energy at any point depends upon the amount of electric charge that are moved towards or away from that point. For convenience, a new term called electric potential was introduced in electricity. Electric potential at any point is the electrical potential energy per unit electric charge at that point. Electric potential equals electrical potential energy over electric charge. Let us summarize what we learned. Electric charge also flows from a higher potential to a lower potential. Unlike charges attract, and like charges repel each other. Electrical potential energy at any point depends upon the amount of electric charge that are moved towards or away from that point. Electric potential at any point is the electrical potential energy per unit charge at that point. It can be mathematically expressed as electric potential equals electrical potential energy over electric charge. We know that work is involved in storing energy. We know a ball at a height has potential energy. But how did it get that energy? We did some work by raising it to that height. Electric potential is basically electric potential energy stored. So how is it related to work done then? We will research on this in our upcoming sessions.
Keep imbibing. We believe in you.